Welcome or welcome back at C Square. In this lesson we'll talk about prism and cylinder. We're gonna start with prism, and you see here the definition of a prism, and also what the lateral face is, and also what the height is. The lateral faces are faces like this one, A, B, E, F, D, H, G, C. The one up front here, A, D, H, E, and the back one, F, G, C, B. And very similar for the others three prism. By the way, the name of this prism is based on the base. This is a rectangular prism because the base is a rectangle. The second one is a triangular prism. The base is a triangle, and the last one is a pentagonal prism because we have a pentagon as a base. The height of the prism is the length of the segment that is perpendicular on the basis. So, for example, like this segment, all these four can be called the height of the prism. All four are the same, they are congruent. And the first thing we're going to take a look, it's what we call the volume of a prism, which has a formula, is right here. Volume equals capital B, which stands for the area of the base, very important to remember that, times the height. The same thing for this triangular prism. So let's see the lateral area I mentioned before. The lateral area is the sum of the area of the lateral faces of the prism, which I show you. There is a formula that I'm going to use it also in this lesson. That P stands for the perimeter times the height of the prism. The lateral area is P times H. And those are only the faces that I showed you a couple minutes ago. The surface area, on the other hand, you add the bases, and you see that in the formula right here. So after you do the lateral area, you add the two bases. In this case, these two bases, top and bottom of the prism. So let's see this first example where we are asked to find the volume and the surface area of the prism below. So the volume, I'm going to start with that, is area of the base times the height. That's the formula I'm going to use. Area of the base. So this is a rectangular prism, by the way. We can consider any face a base, but I will say this is the base in our case. And that is 5 by 6. So we just do 5 times 6. And this is 30. For finding the volume, we're going to go back in that formula. I just put it a minute ago. When we have this 30, the area of the base times 10. 10 is this height. So the volume will be 300 cubic units. You should be aware that the volume is measured in cubic units. Let's move to the second part where we have to find the surface area. So for the surface area, I'm going to show you a different way. We can use that formula we had before, lateral area plus the two bases. That, in fact, that's the formula I'm going to use, but I'm going to start with the lateral area. And in this case, I will suggest you to have this in your mind. Can you find the lateral area of, if you do not remember that formula we just said before, perimeter times the height? The answer is yes. Think about what you have here. And we have this face here, H, G, C, D, and this face here, E, F, B, A. Since this one is a rectangular prism, they are the same. So that's the reason I'm going to put here 2, because we have 2 of them. And these faces, each one are 6 by 10. So that's the reason I'm going to put here 6 times 10. But are those the only two faces? The answer is no. We had the front, E, H, D, A, and the back, F, G, C, B. Those are the same. So again, I'm going to put the number 2 here, times, and how much is that face? The one here up front, this is 5, and don't forget this is 10 also, because they are equal. So 5 times 10 here. So in case you do not remember this formula, you can use this approach, see what kind of faces you have. So here we have 2 times 6, 12, 120, the first part. And the second one, 2 times 5, 10 times 10, 100. So the lateral area is 220. So be careful the difference between lateral area and surface area. Now we're going to move to the surface area, and I'm going to use the formula I just said before. LA, lateral area, 220 plus 2 bases. 2 bases, 2 times, and you remember the base we did it here is 30. So we're going to have 220 plus 60, and that will be 280 square units. Very important, the surface area and the lateral area are measured in square units. Okay, since the volume is measured in cubic units. Let's move to the second example. The second example, we have a triangular prism. The base is a triangle. This is the base. Let me put a capital B here, which stands for the area of the base, different than the B, that is the vertex of the triangle. So the question is, can we find the area of this base? So you see, you notice this prism is in a different orientation, I can say that. And let's take a look here. AC is 3, this is 3, and BC is 4. Okay, so we have enough information. You notice the triangle ABC is a right triangle, so we can use again volume equals area of the base times the height, and that base, since this is a right triangle, we're gonna have 1/2 times the base and the height for that triangle. Let me be sure, are 4 and 3. So we're gonna have here 1/2 times 4, that is 2 times 3, this is 6. The area of this base of this triangular prism, this triangle, it's 6. So the volume now is going to be this 6 times the height. The height is AD or BE, but AD is given to us, and this is 10. So 6 times 10, so the volume is 60 cubic units. Whatever the unit is, that will be the way you measure the volume. Let's see the surface area, and in this case I want to show you how to use that lateral area equals P times H. Remember, P stands for the perimeter of the base, and this perimeter is these 3, these 4, so we're going to add 3 and 4, and we have one more side, this one. In this case, it would be great if you remember this Pythagorean triple, very important, 3, 4, so this is 5. It does work in this case. Remember, this is a very, very important Pythagorean triple. Let me write here. Okay, so very important to remember this. It makes your life easier. If you do not remember, obviously you can use the Pythagorean theorem, a squared plus b squared equals c squared. You just plug 3 and 4 and you find c. Okay, you can double check, the c will be 5. So we have 3 plus 4 plus that 5 I mentioned, so that will be 7, 12 units. Perimeter, remember, is just units. So when we can move to the lateral area now, which is going to be this 12 times the height, which is 10, so that will be 120 units. 120 square units, let me be sure. Surface area, if you remember, is the lateral area plus the 2 bases. So we have surface area equals 120 plus 2 times what? 2 times 6. The area of the base is 6. So we have here 120 plus 12, so that will be 130. This is the surface area. So this formula is very good if you remember the lateral area equals P times H. It can help you to move faster. Let's see another example here, very similar. We need to find the volume and the area of the prism below, but now the triangle ABC is not a right triangle, is a equilateral triangle where AB is 6 and AD is 10. AD will be the height, by the way. Okay, so you notice I label this information given to us. Let me start with this triangle ABC, which is mentioned is a equilateral triangle. Okay, so how do we find the area of this equilateral triangle? There are many ways. You can check my YouTube channel and you'll find more ways to do this. I'm going to show you this way. This is the height of this equilateral triangle. So we're going to have two triangles there. I'm going to take one of them. Let's say the one on the left. This is not going to be 6 anymore. It's cut in half because in an equilateral triangle, the height also bisect this opposite side. So this is going to be 3, and obviously since this is an equilateral triangle, this will be 6. The question is how much will be this segment. Very simple, if you remember, this is 30, this is 60, and using the special right triangle or trigonometric ratio if you want, you will see this one is going to be 3 square root of 3. So I think now we have everything we need. So let me be sure I can write that square root of 3 better. So 3 square root of 3 is the height of the equilateral triangle. So now we can move and get the volume. The first part, volume, if you remember, it's area of the base, this capital B times the height. The base here now is an equilateral triangle, but the formula is the same, 1/2 times the base of this triangle, of this equilateral triangle, which is this 6, times the height. Remember, we just found out the height using special right triangle is this 3 square root of 3. So we have here 1/2 times 6, that is 3. We can simplify like this, and we have 3 times 3, that is 9 square root of 3. I'm going to keep the answer in this format. This is the area of the base, 9 square root of 3 square units. And we can move to the volume now, which is this base, 9 square root of 3 times the height. You remember that height is this 10. And we end up with 90 square root of 3 cubic units. Very important, remember volume, cubic units. And now we can move to the second part, the lateral area. By the way, if you need to evaluate, you need a calculator and for square root of 3 and multiply by 90. Lateral area, if you remember, I'm going to use that shortcut, the perimeter times the height. The perimeter of this shape, right, is what? 6 of this base, 6, right? It's an equilateral triangle, so we have 3 times 6, that is 18. And now we can find the lateral area. Multiply this 18, the perimeter, times the height, that 10. And we end up with 180. Of course, you can use the first approach we did on the first problem. If you remember, 3 faces here, and all these 3 faces are the same, 6 by 10, if you want to call them like that, which will give you 3 times 60, 180. So let's move to surface area, which is this lateral area plus 2 bases, the 2 equilateral triangles. So we have surface area equals 180, the lateral area, plus 2 times this 9 square root of 3. So in this case, I'm going to leave the answer in this format. 2 times 9 is 18. If you need to simplify, evaluate in fact, you need a calculator. Other than that, this answer cannot be simplified. These two, 180 and 18 square root of 3, are not alike. On the second part of the lesson, we're gonna cover cylinders, and you see here how a cylinder looks like. Very similar to a prism. The only difference, the bases are circle. This is one base, and this is the other base. So obviously, we can use the same formula. Volume equals base times height. You see it here. The only thing probably I would suggest you, if you remember, that's good. Pi r square is the area of the base, because it's a circle and the radius is this guy. So you can use this shortcut in case you remember. Volume equals pi r squared h. The height, yeah, it's a segment like this. You see it here. These two heights. Of course, there are plenty of heights in this type of shape. Any segment that is perpendicular on the two circles and is on the lateral face is a height. The volume, I said here, it's what I just mentioned. The surface area and the lateral area. Then let's take a look. The lateral area, do you remember, it was the formula was the perimeter times the height. Yeah, but the perimeter of the circle is the circumference, and that is 2 pi r or pi d. Either one would be good. So that's the reason you see these two formula here. The lateral area is 2 pi r h or pi d h. And the surface area will be the lateral area plus two bases, and you see a formula that, if you remember, is very useful. Okay, and by the way, this is the lateral area that goes around the cylinder, and you can see this rectangle here has a length of 2 pi r and the height of h. That's the reason it works, what I just said here. Let's see this example. Find the volume and the surface area of the cylinder below in terms of pi. So let's do the volume. If you remember, it's area of the base times the height, if you do not remember the formula. But I think you should remember the base is a circle, and that will be pi r squared. And in this case, we have pi times 6 squared. We don't really need a parenthesis here. I just want to see how I replace the radius in the formula with this 6. So we end up with 36 pi. Let's keep it like this, don't do any evaluation. And we can move to the volume now, which is going to be this 36 pi, the area of the base, times the height, which is 8. So we just have to do 36 times 8 in this moment. Nothing else, and that will be 288 pi. 200 and I'm sorry, let's be sure, let's go close to that equal sign. 288 pi cubic units. Again, very important to remember, volume is in cubic units, whatever the units are. Let's move to the second part, the surface area, and we're gonna start with the lateral area. Lateral area, if you remember, it's the perimeter times the height, and in this case the perimeter is the circumference of the circle, which is 2 pi r. So in our case it's gonna be 2 pi, and the radius is 6, so that will be 12 pi. One more step to find the lateral area, and that will be this 12 pi times the height, which is 8, and that will be 96 pi. Lateral area is 96 pi. And we can move to the surface area, the last part of this problem, which is this lateral area plus the two bases, the two circles, the bottom and the top. So we have here surface area equals 96 pi plus 2 times 36. 36 is the area of the base, you see it here. So that will be 96 pi plus 72. And by the way, I forgot to put a pi here, 36 pi. So 72 pi here. So the final answer is we can add these two quantities. They are alike. They have both pi in it. So we have 8 and 7 plus 9, 16. 168 pi is the area or the surface area of this cylinder. And let's move to the next example, a very similar problem. The only difference, now this one is not the radius, is the diameter. So very similar approach. The area of the base times the height. The base is pi r squared. There is no other formula, by the way, for the area of the base, the circle. Now we heard that 8 is the diameter. Like I said, the radius will be half of this diameter. So in this case, 8 divided by 2, and that will be 4. So we have here pi times 4 squared. Again, you don't really need the parentheses. I just put it to see how we replace r of 4. So the final answer for the area of the base is 16 pi the circle. 16 pi square units. We can find the volume now, and that will be 16 pi times the height, which is 10, and the volume is 160 pi. Let's move to the second part, the surface area. In fact, we're gonna start like with the lateral area, which is perimeter times the height. The perimeter is the circumference of this circle. We can use that pi d I said before times h. So in this case we have pi times 8 times 10. So we end up with 80 pi. This is the lateral area, 80 pi square units. And let's move to the surface area. Surface area, if you remember, the formula is the lateral area plus 2 bases. So it's going to be this 80 pi plus 2 times 1 base is 16 pi. So that will be 80 pi plus 32 pi, and that will be 112 pi. This is the surface area of this cylinder. Again, square units in case you need that. In the next problem, we're gonna take a look to some other problem involving prism and cylinder. The volume of a rectangular prism is 480 cubic centimeter. What are the possible dimensions of the length and the width of the base of the rectangular prism if the height of the prism is 17 centimeters? So we know the height of this guy, any of these segments, so I will say GC, this is 17 centimeter. We know the volume, which is 4080 cubic centimeters. So in case you see something like this, that's the meaning. Okay, so in that formula we have before, volume equals area of the base times the height. We can replace this volume and this is the height. So let me write that here. Height is 17, so we have here 4080 equals B. This is going to be the variable, let me go like that, we need to find out, times 17. How are we going to find this B? Divide by 17 to cancel this 17. Do the same thing obviously on the other side. So we end up here with B equal 4080 divided by 17, that will be 240. Okay, so, and by the way, this one is going to be square centimeter, and this is that B. A, B, C, D, that rectangle, right? Because it says it's a rectangular prism. So the question is, can we find any choices for which this area will be 240 square centimeter? Of course, you can find plenty of them. One of them can be 10 and 24. That would be 240. Okay, so the length 24 and the width 10. That's one choice. Can we have another one? Of course, we can have 20 times 12. That is still 240. So I gave you two choices. Of course, you can have more than that, and sometimes you can even have decimal. But I'm going to stay with these whole numbers. I think it's good enough to see. At least there are an infinity choices, but you see two choices here. Okay, so any of these could be the answer. And like I said, you can have more choices. My next example will also be a real-life application. We have this company that needs to decide how to package the container. The first container has a height of 5 inches and a 2 by 2 inches square base, so something like this. Let me try to draw a picture. It's a rectangular prism. One way to draw a rectangular prism is this way, in case you needed to visualize what you need to do. Okay, something like this. I think it's a decent picture. And like they said, the height is 5 and 2 by 2. This is the base. The second container is a cylinder. Okay, how can we draw a cylinder? Draw two circles, something like this, and there you go. This is a cylinder. With a height of 5 inches, the same height, and a diameter of 2 inches. This is 2. Which container will hold most premium cat food? So that's a good question, because in fact it tells us something that we really worry about. Which volume is larger? Because that is about which container will hold the most premium. The rectangular prism or the cylinder. And you notice the number are very similar. So the volume of the prism will be area of the base times the height. The area of the base, since is a square in this case, a rectangle, it's okay if you say that, will be 4 square inches if you need the units. And the volume will be this base times the height of 5. So the volume will be 20 cubic inches. So I'm going to write it like this. That's the meaning. in case. So this is the prism. By the way, I'm going to put here prism. And let's move to the cylinder. The formula is the same, if you remember. Area of the base times the height. The only difference, the base here is a circle. We have pi r square. Okay, how much is the radius? If you remember, this is the diameter, and the diameter is 2. The radius will be half of this diameter. And that will be 1 inch. So times, so we're gonna have here pi times 1 square, which is 1. So the area of the base is just pi cubic. No, just square inches, I'm sorry. And now we can find the volume of the cylinder, which is this area of the base, pi times the height, which is the same, 5. So we have this 5 pi. The question is, which one is contains more food? Which volume is larger? This one or this one? You can take a calculator, and obviously this one nothing to do, it stays as a 20, and by then 5 times 3.14, or find pi in your calculator if you have a calculator that has pi in it. You will see it, the volume of the cylinder is less than the volume of the prism. That's the meaning of this sign. So which container will hold the most premium cat food? This one. And if you want to find out by how much, you just do 20 minus 5 pi. I can do that on the calculator. I end up with 4.29 cubic inches. That is how much more the rectangular prism contains than the cylinder. My next example, and I think is the last one, it is this one where we have two cylinders which model some wedding cakes. The small cake is enough to serve 16 people, so this one is gonna serve 16 people. We're wondering how many people we can serve with this one. So first of all, what do you think we need to find out here to get what we are asked for? We need to find the volume of this small cake and also then we need to find the volume of the large cake. Both of them are cylinder. I'm gonna start with the first one, and again the same formula, area of the base times the height. In this case the base is pi r square times the height. I'm gonna move a little bit faster. What is that? Pi times radius. If this is 10, the radius is gonna be 5. Why? Because we cut that in half. 5 square times 8. Okay, so we have here 25 times 8. If you do the math, and that will be 200. That is the volume of this cake, 200 pi. And you notice the units are the same, inches. So we're gonna need this one, and we're gonna need to move to the second one. I'm gonna change the color to make a difference, but of course you can just keep it the same, no problem. The same formula, area of the base times the height, the same, pi r square h. The only difference is what? H is the, I'm sorry, the radius, right? the radius will be 7 because this is 14, cut it in half. 7 square times 8, the same height. So we're going to have 7 squared, that is 49, and 49 times 8, that will be 392 pi. Cubic inches, by the way, in case you need the units. Okay, very important, the units are the same on both cylinders, on both cakes. So now, look at here what I will suggest you to do to finish this problem. Right proportion, what do I mean by that? The first cake, which has a volume of 200 pi, remember we did find out, is right here. We are able to serve 16 people. Okay, and the second one has a volume of 392 pi. How many people? So you see, I use proportion here, which I think are very good in a lot of problems in geometry and not only. So how do we solve this one? We're going to do cross multiplication. I have 200 pi times x equals 16 times 392 pi. So if I want to solve for pi, I need to divide by 200 pi. That will allow me to get rid of the 200, allow me to get rid of pi. Don't forget to do the same thing on the other side, obviously. So 200 and pi, we divide by these two guys, the right side. So this is the exact answer. The only thing maybe you want to do here is to simplify if you do not have a calculator. And by the way, you can simplify the pi first here. That is something that you want to do there, I think. Over 200. A lot of simplification here. 16 and 200 both divisible by 4, so this will be 50. And this will be 2. Oh, we can do even more. 2 goes in 50 25 times. So in case you don't have a calculator, we have a simpler form here, 392 over 25. If you don't have a calculator, probably this is good enough. Or maybe not, because we talk about people. So we really want to divide this. I'm going to use a calculator now. And I end up with 15. Oops, there is something wrong here. I assume, let's do it one more time. I'm gonna go back here. I hope I did write the proportion correct. Okay, let's double check. So again, it's going to be x times 200 pi equals 16 times 392 pi divided by 200 pi, like I said before. So these 200 and these 200 cancel out, pi and pi cancel out. So we have x equals, these two pi's cancel out. Let me use a calculator right ahead, right now. And I will suggest you to do the same. 16 times 392 divide by 200. Yeah, this answer makes sense. It's 31.36. Obviously, we need to round it down. This cake can serve 31 people, which makes sense in this case. Another way to look to this problem is to look to the ratio between these two diameters. That will be 14 over 10, which is 1.4. You can square this guy. and it'll be 1.96 and multiplied by 16. You should get the same answer. 31.36. So this is the shortest way. If you remember this one, obviously you can finish the problem you see in just a couple minutes. Okay, if you enjoy this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.